it's time for us to add and subtract our rational expressions. Of course, the first step is always to factor everything that you can. And here's the second step that we haven't had to do in multiplying and dividing. We must find a common denominator for both of our fractions. So we're going to practice doing that before we move on into adding and subtracting actual rational expressions, but let's continue to walk through the rest of the steps. After you've found your common denominator and rewritten your numerators so that they include the common denominator, your next step is to add or subtract the numerators, whatever you're supposed to be doing in that problem. Then you always leave your common denominator as the final denominator after you've add or subtract. And then finally, we simplify if possible. Just be very careful that you are canceling only factors, meaning numbers that are multiplied by the rest of the fraction, not terms, things that are added and subtracted. So when we are trying to find common denominators for monomials, which is what we'll do first, we'll do 1, 3, and 4, we are actually going to do the prime factorization that we talked about in multiplication. So we are going to prime factorize each of these denominators. That means that we're going to need to use a factor tree for the numbers. So we have 4 and 4. You could have used 2 and 8. Each of those 4s get a 2 and a 2. So 16 can be rewritten as 2 to the 4th power. And then the variables just get written behind. For the 8x squared y, 8 can be rewritten as 2 and 4, and then 4 is 2 and 2. So 8 is 2 to the 3rd power, and there's an x squared y behind it. And lucky for us, 5 is already a prime number, so I don't have to do a factor tree. And there's my prime factorization of my denominators. To find the common denominator, what you're looking for is you are looking for the most amount that each factor appears in a single denominator. So the factors that are included in these denominators are 2, there's 5, there's x, and there's y. And we want to know which is the most amount that each one happens in a single denominator. So for example, if I look at 2, the most amount that it happens would be 4 times. So 2 to the 4th has to be included as part of the common denominator. Next, we'll look at the x. The most x's that occur in a single denominator is x to the 3rd. So that's what's going to be included in the common denominator. Now there's a tie for the y's. We still just include 1 because that's how much was in a single denominator. And then the only other thing I haven't written down yet, or only other factor I haven't written down, is the 5. And it occurs only once. So my common denominator will happen when I actually multiply all of these together. 2 times, 5 times 2 to the 4th. And you get 80. And then there was an x cubed and a y. There's our common denominator. We're going to jump down and do number 3. Keep in mind I chose easier numbers that you would probably be able to find a common denominator with number-wise without this process, and that's just to help get you used to the process. So I do encourage you to do the prime factorization process. So for 12, we have 6 and 2, and 2 and 3. So prime factorization would be 2 squared times 3, and there's a c. Now for 6, we have 2 and 3, so 2 times 3, and there's a c squared and a d. So the common denominator, which one has the most amount of 2's? This one. So 2 of them will be included. What's the most amount of 3's included? Just 1. It's kind of a tie. Most amount of c's, 2. And most amount of d's is 1. So 2 to the 2nd times 3 gives me 12. c squared d. Let's do the last monomial one before we take a look at the polynomials. Prime factorization for 18, 6 and 3, 2 and 3. So we'll have 2 times 3 squared a cubed b c squared. Then for the 24, we can do 6 and 4, 2 and 3, 2 and 2. So there are 3 total 2's, 1 3, b squared, c squared. So when I go to include my common denominator, the most amount of 2's is 3 of them, and that happens in the second one. Most amount of 3's is 2 of them, happening in the first one. Most amount of A's, 3 of them. Most amount of B's, 2 of them. And most amount of C's, there's a tie for 2 of them. So 2 to the third times 3 to the second gives us 72. A to the third, b squared, c squared. What happens when they're polynomials? Well, we still have to factor, we're just not using prime factorization. The process is still going to remain the same. So number 2, we're going to need to factor by taking out a GCF, which would be 3y, and that leaves us with y minus 3. For our second fraction, we'll need to use a times c. So a times c is 15. Factors of 15, 1 and 15, 3 and 5. Multiplying to be a positive, adding to be a negative, means both are going to need to be negative. Here's our box. First term is y squared. Last term is 15. And we're going to need negative 3y and negative 5y. What can come out of the numerator? Y. The denominator, negative 3. The left side, y. And the right side, negative 5. So my denominator factors to be y minus 3 and y minus 5. So when looking for the common denominator, you have factors of 3, y, y minus 3, and y minus 5. The most amount of 3's is 1. The most amount of y's is 1. The most amount of y minus 3's is 1. And the most amount of y minus 5's is 1. So there's our common denominator. Number 5, we need to factor first. So that means taking a GCF out. And lucky for us, our second one is already factored. So when finding a GCF, we need the most amount of 2's, the most amount of x minus 3's. It's a tie for 1. Now here we see that our common denominator actually matches one of the denominators that are already listed, and it's okay. That might happen sometimes. Number 6, 2 perfect squares with a minus in the middle is the denominator of our first fraction. So we have t in the first spot of each, square root of the first term. Square root of the second term gives me 5, 1 plus, 1 minus. And lucky for us, our denominator in the second fraction is already factored. So when listing the common denominator, we have the most amount of t plus 5's and the most amount of t minus 5's. Let's do some practice with some monomials. For number 7, we need to do prime factorization. So 5 and x are already factored completely. 4 can be broken down into 2 and 2. So 2 squared and y cubed. So when listing the common denominator, we have most amount of 5's, most amount of x's, and the most amount of y to the thirds, the most amount of 2's. When we're looking at the denominator, we want to take your original denominator and we are going to be multiplying it by whatever the original denominator is missing. So we'll figure that out in just a second. But original numerator by whatever the original denominator was missing. Now let's talk for a second about why that is the case. Take, for example, adding 1/4 plus 2/3. So you are in the process of saying 4 and 3, what number can both 4 and 3 go into? 12. We can do that the same way, even with the process that we just did. We have 2 squared and we had a 3. So our common denominator would be 2 squared times 3, which we know that to be 12. It's the same process, just a little bit different, and makes it a little easier if you're struggling to find a common denominator, or even if we're looking at the variables, it can be a little bit tricky if you're not looking at the smallest common denominator. Now, the old way, or I would say the original way that you've learned how to do this, would be to make this have a denominator of 12. And you did that by saying, okay, 4 times what gave me 12? 3, so you'd multiply the top and the bottom by 3. And then over here, you would say what times 3 is 12? 4, so you'd multiply the top and the bottom by 4. So you are multiplying each of these numerators, so 1 in this case, by what the denominator was missing. 4, or 2 squared, was already there, and we are multiplying by 3 to get the common denominator. Over here, we already had the 3, so we were multiplying by 2 squared, or 4. That's what we're doing here as well. So when I look at y, or 12y, as my numerator, we're going to look at the denominator. It does not have a 2 squared in it, so I need to multiply by that 2 squared. It already has a 5. It already has an x, but it does not have a y cubed. How about this one? It already has a 2 squared. It doesn't have a 5. It doesn't have an x, but it does already have y cubed. So we can multiply 12 times 2 squared gives me 48. And y times y to the third gives me y to the fourth. 5x times 5x gives me 25x squared. And 2 squared times 5 gives me 20. Now, students are often very tempted to try to reduce here by either canceling out variables or trying to reduce numbers. But the only way that you would be able to reduce is if you were able to factor the top more so that your factors canceled and not the terms. Trying to do anything else is going to actually be canceling terms and not factors, so be very careful. Let's take a look at the next one. We have 7b over 12a minus 1 over 18ab cubed. So a factor tree for the 12, we have 4 and 3, 2 and 2. So my denominator would be written as 2 squared and a 3 and an a. For the other denominator, 18, we can use 3 and 6 and 2 and 3. So 2, 3 squared, a and b cubed. In finding our common denominator, the most amount of 2's is 2 squared. Most amount of 3's is 3 squared. Most amount of A's is just 1. Most amount of B's is 3. So my original numerator is going to be multiplied by whatever my denominator was missing. This time I'm subtracting my original numerator times whatever my denominator was missing. So we have a 2 squared, but I only had 1 3 up here, and I needed 2 in my common denominator. So we're going to need to multiply by 1 more. I already had the A, but I did not have the B cubed. For the next denominator, I needed 2 2's, but I only had 1 in the original denominator, so I need 1 more. I already have the 3 squared, I already have the A, I already have the B cubed. So 7b times 3b to the third gives me 21, b to the fourth, and negative 1 times 2 gives me negative 2. Over 2 to the second, 3 to the second, which is 36, a, b to the third. And since I can't factor anything out on the top, there's no more factoring to be done. This is my simplified answer. Let's do a few with polynomials. So when I look at number 9, I notice that I've already been given common denominators. Everything's already factored, and all of the denominators are common. So the only thing left for me to do is to subtract my numerators. So my denominator is going to stay the same, and my numerators will be 3a, and 2 minus 7 is 5. So 3a minus 5 over a minus 16. That is what I would consider to be a simple version of addition or subtraction, would be one where there's already a common denominator. And then remember, there's always a complex version as well, where we actually have to find the common denominator. Number 10, we're going to factor first. Lucky for me, the first one is already factored, both the numerator and the denominator. And in the second fraction, the numerator is already factored. We just need to factor the denominator. So I'm going to do that up in the margin above here. A times C is 27. Factors of 27, 1 and 27. 2 doesn't work, but 3 and 9 do. And those are the last factors. We want it to multiply to be a positive and add to be a negative. So 2 negatives. And we'll need to use negative 3 and negative 9. So y squared is the first term, and 27 is the last term. Negative 3y and negative 9y go in the last two boxes. What can I take out of the top, out of the bottom, out of the left side, and finally out of the right side? So my denominator is y minus 9, y minus 3. So everything is already factored. We'll write our common denominator now. So which one has the most amount of y minus 3's? That's a tie for 1. Most amount of y minus 9's? Just 1. Now my numerators are going to be multiplied by what I was missing, plus numerator times whatever I was missing. So y minus 3 is already there. but I did not have a y minus 9, so we'll need to multiply my numerator in the first fraction by y minus 9. In the second one, I have a y minus 9, I have a y minus 3, so I actually don't have to multiply anything in the second one. So we'll go ahead and distribute our 8y minus 72 plus 2y minus 5. That whole thing is over y minus 3, y minus 9. Move that up a little bit for you. 8y plus 2y equals 10y, and negative 72 minus 5 is negative 77. And that's all over y minus 3, y minus 9. Check, can I take something out of this or factor it further? And I can't, so this is my solution. Now, we do, in this case, want to work on writing excluded values, and I did forget to do that in number 9. Our excluded value, remember, is whatever the denominator can't be. So we would set each of these denominators equal to 0, and we get that y cannot be 3, and y could not be 9. If you go back to the previous problem in number 9, you have that a minus 16 equals 0, so a cannot equal 16. We've got 2 more problems to work through, number 11 and number 12. So we're factoring first. I'll take the first one, and the numerator doesn't need to be factored, but the denominator has a GCF. And in the second one, the numerator does not need to be factored. Stays as x plus 1. And the denominator is 2 perfect squares with a minus in the middle. So we have x plus 2 and x minus 2. Now that we've factored it, we'll find our common denominator. Most amount of 3's, just 1. Most amount of x plus 2's, just 1. Most amount of x minus 2's, just 1. So we have our original numerator by whatever's missing, minus, and notice how I'm putting my numerator in parentheses when it has multiple terms. That's because that negative will get applied to both of these terms, times whatever it was missing. So I had a 3 already. The x plus 2 was already there. The only thing it was missing was x minus 2. And over here, I already had an x plus 2. I already had an x minus 2. The only thing that was missing was 3. We're going to need to go ahead and distribute this 4. So we get 4x minus 8. We're going to distribute this negative. So we get negative x plus 1. And that whole thing is going to need to be multiplied by 3. You could have multiplied the negative by the 3 and then distributed it, but you're still looking at 2 separate steps unless you did the negative 3 in your head. So distributing the 3 to that numerator, we'll have 4x minus 8 minus 3x plus, minus, I forgot to distribute my minus. I even drew my lines and everything. Minus 3. And the reason why I like to distribute the negative rather than just remembering that you're subtracting is that unfortunately a lot of us forget that we are subtracting partway through and either one or more terms don't get subtracted. So we're going to simplify. 4x minus 3x is just x. Negative 8 minus 3 is negative 11. All over 3x plus 2, x minus 2. Let's take a look at number 12 for our final problem. We're going to factor everything that we can. I'm going to go ahead and do a times c for my denominator. We have 18 for my a times c, 1 and 18, 2 and 9, 3 and 6. We want it to multiply to be a positive and add to be a positive. So this is what's going to give me 9. X squared and 18, along with 3x and 6x. I could take an x and a 6, an x and a 3 out. So my first fraction, 4x is already factored, and the denominator we just factored to be x plus 3 and x plus 6. Lucky for me, my second fraction is already factored both in the numerator and the denominator. So when we go to write our common denominator, most amount of x plus 3's, just 1. Most amount of x plus 6's, just 1. So we're going to now find what we're. The first one, the numerator was 4x, and x plus 3 was already there, x plus 6 was already there, so I didn't have anything that was missing. Plus 5, and I already had an x plus 6, but I did not have x plus 3. That 5 needs to be distributed. 4x plus 5x plus 15 all over x plus 3, x plus 6. 4x plus 5x gives me 9x plus 15, oops, all over x plus 3 and x plus 6. Now we always want to try to leave this in simplified factored form. And if I look at the numerator, I see now that I have, for the first time in our notes, I have a GCF that I can take out of my numerator, which means there's a potential to be able to cancel something out. Even if you can't cancel something out, you should always try to factor as far as you can. That's what the directions are going to request you to do, because you have to simplify. So I can take a 3 out of both, and that leaves me with 3x plus 5, and then x plus 3 and x plus 6 in the denominator. Unfortunately, I wasn't able to simplify any further by canceling, but I did factor further for a simplified answer.